Hello everyone. Today we are going to learn how to interpret a speed time graph. The speed is on the y-axis and the time is on the x-axis. The units can vary. Time can be in seconds, can be in minutes or hours. And speed, the unit can be meter per second or kilometers per hour. In this example, I choose time in seconds and speed in meter per second. Now, this point here is 0, 0. What does it mean? This means this is when time is 0. That means in the beginning, and the speed is 0. That means in the beginning, the speed of this moving object is 0. This represents an object moving at constant speed of 3 meter per second. What is constant? Constants mean the value never change. Now look at the graph. Okay? When time is 0, the speed is 3. When time is 1, the speed is still 3. When the time is 10, the speed is 3. So, as time passes, the speed does not change. So, this is motion at constant speed, represented by a horizontal line. Horizontal line in a speed time graph represents constant speed motion. If the line is here, it means this object is moving at constant speed of 0 meter per second, because as time increases, his speed is always 0. Now, an object that is moving at 0 meter per second is not moving at all. So this object is stationary. Do you know how an object moving at constant speed move like? It moves like this. Every second, the object covers equal distance. So, once again, how about an object moving at 0 speed? It'll be like this. Negative b plus or minus the square root of b squared minus 4ac over 2a. Not moving at all. How about this? In this case, the object is moving at increasing speed. How do we know? At 0, the speed is 0. When time is 1 second, the speed is, okay, let's say 1. At 2 seconds, the speed is 2. At 5 seconds, the speed is 5. So, as you see, as time passes, the speed increases and thus increasing speed. So, a straight line like this represents motion at increasing speed. But there's more to this actually. Now, if you were to calculate the gradient of this line, do you remember how to calculate gradient? It's y2 minus y1 over x2 minus x1. So, if you choose any 2 points on this line and calculate the gradient will always be the same. Okay? In this case, the gradient is 1. But no matter what, whenever you have a straight line and you use any 2 points on the straight line to calculate gradient, the gradient is always the same. When we say gradient is the same, we say gradient is constant. Okay, in a speed time graph, what do you think the gradient represent? Okay, now let's use logical thinking. As time passes, speed increase. Okay, that means you are getting faster and faster. What word describes that, getting faster and faster? If you think carefully, that means acceleration. Okay? So in a speed time graph, the gradient represents acceleration. Remember, in a distance time graph, the gradient represents speed. Over here, the gradient represents acceleration. And recall, acceleration is getting faster or getting slower. So when we combine constant gradient and the gradient representing acceleration, whenever you see this kind of straight line in a speed time graph, we say the object is moving at constant acceleration. That means this object is speeding up, but speeding up constantly. Now, how does an object moving at constant acceleration look like? It will look like this. I repeat, it will look like this. So it is speeding up, but speeding up at constant acceleration. How about this? Can you see that this object's speed is decreasing over time? As time increase, the speed decrease. So this is decreasing speed. Now relate to just now. This will be decreasing speed at constant deceleration. So this is the opposite of constant acceleration, which is constant deceleration. Okay, the other word for deceleration is slowing down. Just now the line go up is constant acceleration. Over here is going down, it is constant deceleration. This object is slowing down. So come everyone, let's combine everything and let us interpret this graph. From 0 to 3, the object is moving at increasing speed at constant acceleration. From 3 to 8, the object is moving at constant speed of 10 meters per second. From 8 to 9, the object is decreasing speed at constant deceleration. So he is accelerating, constant speed, and decelerating. Yo, I am smart. Okay everyone, let's put on our thinking heads and look at this. Let's say I have object A moving like this and object B moving like this. As you all know, straight line means moving at increasing speed and at constant acceleration. Can you tell me which object, A or B, is moving with a greater acceleration? Meaning, which object is speeding up the most? If your answer is A, you are correct. Because A has a larger gradient than B. Therefore, A has a larger acceleration than B. And therefore, A is speeding up much greater than B. So, in summary, for a speed time graph, this type represents motion at constant acceleration. The speed is increasing but at constant acceleration. This part represents motion at constant speed. And this part represents motion at constant deceleration. So speeding up, constant speed, slowing down. And the gradient of all this line represents acceleration. Alright, and that is the end of the first part.